Hello everyone. In this video we are going to talk about scientific notation. So let's break this down piece by piece. An important example with the use of exponents, which we've been doing a lot of in the last several videos, comes from science. The numbers occurring in science are often extremely large or extremely small. Because of the difficulty of working with many zeros, again, whether if a number is small or large, we often express numbers in this form, which is what scientific notation is. So a times 10 to the power of n. A, in this case, is a number that is equal to or greater than 1. At the same time, that number is also less than 10. So to put that into perspective, A is in between 1 and 10. So it's any number that can also include 1, but it is less than 10. It cannot be 10, because if that were the case, we can go up a whole nother place value. N is any integer. So a times 10 to the power of n. This explains the notation known as scientific notation. There is always one non-zero digit before the decimal point. So let's take a look at a couple of examples for what this notation looks like. Write this right over here. Some examples of scientific notation could be 3.5 times 10 to the power of 2. Another example could be 5.62 times 10 to the power of 3. And one more. I'll write it up here. 9 times 10 to the power of negative 4. Now again, the exponent can be negative. This just indicates that this particular number is small, meaning it is less than 1. These indicate rather larger numbers, meaning they are bigger than 1. So how do we write a number in scientific notation? I have a couple examples coming up in just a moment. 3 things to keep in mind. Number 1, you move the decimal point to the right of the first non-zero digit. So particularly what we did with these two numbers here. It's 3.5, 5.62. It's always going to be a number between 1 and 10, not including 10. Remember that. Number 2, to figure out the exponent on 10, you count the number of places that you move the decimal point. And we'll go over a couple of examples in just a moment. Lastly, to decide the sign of the exponent, you look at the original number, whatever a was. So if it was 10 or larger, the exponent is positive. If the original number was between 0 and 1, then the exponent is negative, much like how this example was. So let's look at a couple of examples right over here. So the first two numbers are classified as large numbers, quote unquote large numbers, because they are larger than 10. So this first number is 93 million. If we were to convert this into scientific notation, our decimal point's over here. So if we count the number of spaces that we move our decimal point, we'll get the number for scientific notation, which remember has to be in between 1 and 10, but not including 10. So every third placement is where we have that comma. So 1, 2, 3, 4, 5, 6, 7. So this is 9.3 times 10 to the power of 7. 7 because we moved that decimal point exactly 7 spaces to get that number in between 1 and 10. This next one Our decimal point is right here. So 1, 2, 3, 4, 5. This number is 3.021 times 10 to the power of 5. Another large number. One more. Here I have 0.00462, so this is considered a small number. Now I got to move my decimal point to the right until I get a number in between 0, or rather a number between 1 and 10. So 1, 2, 3. Right there. So this ends up being 4.62 times 10. Now because this number was less than 1 but bigger than 0, this exponent is negative. So we moved it 3 spaces. That exponent will be -3. We'll go over more of these in another video, and then converting between standard form and scientific notation. Thank you so much for watching, and I will see you later.